Hello friends, welcome to my channel, that is Hariharan Express channel. Today I will discuss another topic, that is CPU organization for different instructions. That means how different instruction is explained through CPU organization. Whenever we go through CPU organization, first of all we go through what kind of components are used under CPU organization. Okay, so before discussing regarding on CPU organization for instruction, first of all we see that what are the fields or how many parts of a particular instruction. We have already discussed that is a instruction format. Based on that we have to assign or we have to explain different parts of the instruction, how it will execute through CPU organization. So if you go through instruction format, normally we know that instruction format having three parts. Okay, three parts. One part is a address part, another part is a opcode part, another part is a mode. We can tell as it is a mode part. Okay, if we, that is very simple. That is the instruction format is defined in this way. Very simple way we can define instruction formats. So address part means address part for operand. Opcode part is a different operation we can consider for the in this that is a part, that is a different operations, maybe addition, subtraction or any other operations. Mode part is used for, that is when you access data directly or indirectly. Okay, if we go through directly, then this is the I for mode. I is equal 0, direct address data. If we go through I is equal to 1, then indirect address data we can access. Okay, this is indicated by this particular I mode or a mode, and mode is only one bit, either 0 or 1. 0 and 1, if it either 0 or 1, it indicates that is the data accessed directly or indirectly. This is the basic concept of instruction format. And come to the point, whenever we go through this part, then we will see that how it is designed and how it is defined through CPU organization for any kind of instruction. Suppose any kind of instruction is given, how CPU organization help to define or explain for any kind of instruction. Normally most of the computers that is use the three types of organization, not three types of CPU organization. So three types of CPU organization I will explain that one. Three types of CPU organization. Okay, three types of CPU organization. Those one I will explain, so we can easily find out that. First one we go through, that is single accumulator. Single, okay, accumulator. Okay. Organization, single accumulator organization is the first type of CPU organization. And second one is you can tell general register organization. Okay, second one. And third one we can write third one, that is a stack organization. Okay, third one is a stack organization. Okay, so the three category of organization are involved in the that is a CPU organization. Through this is three category of CPU organization used for different instruction, or how instruction is defined through CPU organization. Okay, okay, so now we will discuss that different that is instructions through these above organization. Okay, So normally I will just explain how it is defined through different instructions. The instruction, actually the instruction format in this type, that is a computer in the different types of format in computer that uses one address field. Okay, suppose instruction having one address field, then what happens, that that address field defined through instruction and specifies the particular, suppose arithmetic operation, that is addition, subtraction or anything. Okay, further, that is any assembly language, very simple way we can also define. Okay, if we go through that is single accumulator, for example we will go through the single accumulator, how it is defined or which kind of instruction defined through single accumulator organization. Okay, this single accumulator organization, first case we will consider. Okay, like first one, single accumulator organization. Okay, single accumulator organization. So in which case this particular single accumulator organization is used? Very simple. If instruction have a single or one operand, then it is used through this single accumulator organization. For example, we can go through, that is a example we can take, that is add x. Okay, add x. That means x contains the address of the operand. X is one operand. This address contains this x operand, but add instruction in this case, the result of operation, how we will operate through this particular x. X is one operand, but addition of addition, when add or any kind of arithmetic operation, it needs two operand, but here is that is one operand. Then how to add this operand? Okay, with the help of this accumulator we can add. Very simple way we can go through this add operation. If instruction having one operand, then what happens, with the help of accumulator we can add. Okay, this is the basic concept. So now we see this particular instruction can be defined in this way, that is I see here one operand collect from AC plus this another is memory, because if this is x, y, z, whatever the number excluding register, it is mentioned a, b, c, x, y, z like this, but it is defined through that memory. Okay, memory is defined in this manner. So we collect the data from memory, that is m address, x address or x data, add with the SC and store in SC. Okay, this is the basic concept. If we go through accumulator register, that add with the accumulator register content or data with the memory data. Memory data is x. This x data will add. This is a very simple expression whenever go through this single instruction, or like a instruction having add, single any kind of operation, add, multiplication, subtraction or anything. Okay, with the any data. If this kind of instruction is there, then we go through single accumulator organization. Okay, that means the expression is defined in this way. If we go through multiply, similarly SC multiply with the MX, subtraction SC must subtract with the MX, like this. It depend on that. If one operand is given, definitely we will go through single accumulator organization. This is the basic concept. Next, go to that is other way also we can define. Okay, that is second part is a general register organization. Second part is a general register organization. So how it is defined? General register organization. General register organization. How it is defined? Okay, that means we will use register only. Okay, whenever you use a register, then we go through general register organization. Means different register we can use, maybe R1, R2, R3, number of register only used. Okay, sometimes we use also, that is memory, both memory and register also sometimes use, but register must, since it is a general register organization. Okay, so different example we can take it, like suppose R add R1 R2, R3. Okay, then what happens? Very simple way. The content of R1 we can write in this way. R1 is R1 plus R3. Sorry, R2 plus R3. In this way we can write. Okay, that is the content of R2 and R3. Sum of content of R2 and R3 store in R1 in this way. Here this particular R1, here R1 is a destination. We can write a destination, and R2 and R3 both are source. Okay, both are source. So some computer also use another way, like another way. This one register another way they can also use. Last one is a destination, first two is a source. Some case also we can use like R3 is equal to R1 plus R2. In this case what happens? It is a source, sorry, it is a destination. Okay, it is a destination and both are source. Okay, both are source. In this way also we can generate through generator for operation, means add operation, where R1 sometimes use for destination, R2 R3 are source, or reverse some other cases sometimes it depend on the configuration, computer configuration. R3 also use for destination, R1 R2 use for source. Either or case, two cases is true, no problem. Okay, and other part, other also sometimes what happens, we just move some data from a register to one register to another register. Very simple way, that like a move R1 R2 for example. Okay, that means move R2. Okay, R2 there is two ways we can write, that is R1, the content of R1 transfer to R2, one way. Other way also we can write like R1 means content of R2 move to R1. Okay, either or case also we can consider. Okay, this is the another way. So different ways also we can consider for this whenever we will use general register organization. Similarly another case, sometimes both that is memory as well as register also use. So general register type computer employ 2 or 3 address fields in their instruction format. Each address field may specify sometimes, okay, may specify processor register and memory word also. Sometimes here is specific general register, sometimes use memory as well as register. In that case, for example, we can take like add R1 X. Okay, add R1 X. In that case, one part is register, this part is a register. Okay, this part is register, this part is a memory. Okay, in that case, how to define? Very simple way, that is R1. Okay, R1 plus that is a memory of X. In this way we can write. Okay, that means some content of a register and some content of a memory, sum of that two content store in a register. In this case we can define in this way. Okay, this is the basic concept regarding on general register use, register organization. So either go through directly only register, or sometimes we consider for or consider through this register as well as that is a memory. In this way we can define register organization for different category of instructions in this way. Okay, so last one is we can see, that is a stack. Okay, that is a stack operation or stack organization we can write, that is stack operation or stack organization. Okay, last one is we can write stack organization. Okay, stack organization means it has actually no that is addresses, no addresses, operand address, no data address or operand address are there. That is not fixed actually, because we know that whenever operation through any kind of data, the data will be operated, but there is no fixed address. For the reason we can tell as a zero address. If we go through stack organization, that is a we can tell as a zero address, means there is no address fixed. Okay, in that case what happens is only just a push, pop or some certain operation we can use. So normally what happens, normally if you enter some data, we can use push operation. If we delete some data, we can use push operation. This is the basic concept. Okay, and like this, very simple way, it has suppose different data are there like this. Okay, 0 1 2 3. Okay, A B C. If we that is enter some data, it will depend on the SP, stack pointer concept. Okay, if we that is enter some data, then what happens, SP is equal to SP plus 1, enter some data, so data D is entered. Okay, if we delete some data, then what happens, SP is equal to SP minus 1, automatically this data will be deleted. Suppose here SP is 2, we have to delete that, so if 2 is there, so SP will be 2 minus 1, that is 1. Whenever SP will be come to here, that is 1, automatically C data will be deleted. Okay, this is the basic concept of a stack organization. I have already explained this part. And whenever you go through, that is any kind of operation, for example add. Okay, add of data, then what happens, that is add of data, any data, then what happens, it is just receive the top 2 position of data, whatever the data. Suppose here is SPG here. Okay, like I will tell you, for example, very simple example, like A plus B, for example A plus B. Okay, and say here is A, here is B. Okay, A B, and if we that is we go through, that is reverse Polish notation, A B plus, for example A P plus R P N, reverse Polish notation use, then it will convert to A B N. Then it is easy to operate through stack organization. Otherwise some problem may be arise, because which operator will come and how to evaluate. So in this case what happens, A B data is there. Now stack pointer is here. Whenever a plus is coming, suppose that means that operator is coming, then what happens, after that is here when the A is here, B is here. Whenever a plus is coming here, then what happens, it immediately start the operation, that is addition operation of A and B, and store that data here. Very simple way, here is A plus B, and bottom of this can write that is A plus B. What is the addition of the 2 data, store in here. Okay, so this is the basic concept. Whenever any kind of operation used through stack organization, there is no need of that is find out its corresponding data address. Only different data store in a there is stack, and operate according our requirement, what is the operation is there as per the instruction, that operation need to operate. So this is the basic concept of the stack organization for one kind of operation. So I hope I discuss all kind of organization, that is that is single accumulator organization, another is general register organization, another is stack organization. So 3 organization is very important to identify the operand, operator, and operation will be start accordingly. Okay, so I hope all of you understand this particular topic. There is a stack CPU organization for different instructions. So whenever use CPU organization, how it will be useful for different instruction and operate accordingly. Okay, thanks to all. Please subscribe my channel and comment to me to improve my that is videos as well as progress our channel. Okay, thanks to all.